Hi everyone, this is Teacher Jane again, and my topic for today is all about permutation. If you haven't subscribed to my YouTube channel, please click subscribe and feel free to ask questions in the comment section. So I'm going to start with a common situation that most teachers like me would encounter at the start of the school year. And that is how to arrange my three new students, Kevin, Diane, and Nicole, in this row having three chairs. So I'm wondering how many possible arrangement can I arrange Kevin, Diane, and Nicole. So I think the best way is to list all these possible arrangements. So in my list, this is actually what I came up with. So I have three chairs and I'm going to arrange Kevin, Diane, and then Nicole. So that's the first arrangement that I'm going to write. Okay. Second would be Kevin, then Nicole, and Diane. Okay. And the third arrangement, I'm going to place Nicole, Kevin, and Diane. The fourth arrangement could be Nicole, Diane, and then Kevin. Fifth one is Diane, Kevin, and then Nicole. And then I think I only have one last possible arrangement, and that's Diane, Nicole, and then Kevin. Now, let me check if there's an arrangement here that's duplicated. Okay. So far, there's no duplication of arrangements. And so far, they're all unique. Okay, so my conclusion is that I can have 6 possible arrangements for my 3 students for this quarter. The situation involving arranging my students in a row is a clear example of a linear permutation. So what is a linear permutation? It is an arrangement of objects in a line with a definite order. So that line could be a row, a column, or it could be diagonal, for as long as it forms into a line. So what is now the formula in finding the number of possible arrangements of a linear permutation? It is known as NP taken R equals n factorial divided by the quantity n minus r closed quantity factorial, where n is the total number of objects and r is the number of objects selected or taken at a time. So in the case of my example a while ago, the total number of objects that I'm arranging there is 3 because I have 3 students involved, Diane, Kevin, and Nicole. And R there is the number of objects to be selected at a time since there are 3 chairs. So which means I'm going to select 3 students at a time. So R there is also 3. Anyway, you will be familiarized with this formula in my next examples. I'm going to use it in the next example. Now let us go back to the problem, okay, that I have already discussed a while ago, but this time I'm going to use now the formula. In how many ways can teacher Jane arrange her 3 students, okay, in a row with 3 chairs? So using now the formula, NPR is equal to n factorial divided by the quantity n minus r closed quantity factorial, where n is the number of objects and r is the number of objects selected at a time. So step 1 is to identify the value of n and r. So since there are 3 students involved or 3 things that I'm going to arrange, the value of n is 3. And R is the number of objects that you select at a time. Since there are 3 chairs, therefore I have to select 3 students at a time to sit on those 3 chairs. So the value of R is also 3. Then using now the formula NPR, this will become 3P 3. Instantly, in your calculator, you'll just look for the key NPR and you just punch 3P3, you are going to get an instant answer. But for now, we are going to use the formula n factorial. So that will be 3 factorial divided by the quantity n, which is 3, minus r, which is also 3, then close quantity factorial. Okay, so the value of 3 factorial is 3 times 2 times 1. Okay, and then our denominator will be 3 minus 3 is now 0. Okay, you have now 0 factorial. Okay, remember that the value of 0 factorial is equal to 1. So, 3 times 2 times 1 is 6. Then, 0 factorial has a value of 1. So, our final answer for 3P3, okay, is equal now to 6. So, there are 6 possible arrangements, which is also the same as in our experiment by using listing. Okay, now let's move on now to the second example. Now, moving on to example 2, what happens if we reduce now the number of chairs? So, in how many ways can teacher Jane arrange her 3 new students in a row with only 2 chairs available? So, I have here Kevin, Diane, and Nicole, but there are only 2 chairs available. So, let's use again the formula NPR. Okay, is equal to n factorial divided by the quantity n minus r close quantity r. So there will be a difference now in the value of r. So let's write, identify Rn. Rn hasn't changed because I still have 3 students. But R has to change because this time, since there are only 2 chairs, therefore I'm going to choose only 2 students at a time. So this becomes 2. Now, using now the formula, we are solving for 3P2. Now, again, you can instantly get an answer by pressing this in your calculator. You just look for the NPR key. And then, this becomes 3 factorial divided by the quantity 3 minus 2 factorial. Since we know that the value of 3 factorial is 6, 3 times 2 times 1, so we just write it there. And then in the bottom part, 3 minus 2 is 1. So we have 1 factorial, okay, which is also equal to 1. So our final answer is there are 6 possible ways that we can arrange these 3 new students with 2 chairs. Now let us check by listing. So, Kevin, Diane. Okay? Remember, there are only 2 chairs. Kevin, Nicole. So, second arrangement. Third is Diane, Kevin. Diane, Nicole. Next is Nicole, Kevin, and then Nicole, and then you have Diane. So, there are 1, 2, 3, 4, 5, 6 arrangement verified through listing. Now, let's move on now to example number 3. Now, moving on, our next example is in how many ways can teacher Jane arrange her 3 new students in a row with only 1 chair available. So let us see what we will get. So we have NPR is equal to n factorial over the quantity n minus r close quantity factorial. So this time again, N hasn't changed, it's still 3, but we only have one chair left. So 3p1, okay, is equal to 3 factorial over 3 minus 1. So because we are going to take only one student at a time, okay, since we know that the value of 3 factorial is 6, and the denominator will be 2 factorial, which is 2. So 6 divided by 2, there are 3 possible arrangements. Well, that is actually quite obvious because Kevin, okay, has one chance. Diane has also a fair chance of having that one seat, and Nicole. So there are only 1, 2, and 3 possible ways that I can arrange my students. So that's how it is with linear permutation. Now, to wrap it up, it is now your turn to answer these exercises. I have prepared 2 questions, and then I'm going to pause the video for a while for you to come up with your own answer. Number 1, in how many ways can you arrange 4 persons in a row? So, this is your guide. The solution, NPR is equal to n factorial divided by the quantity n minus r close quantity factorial. You can actually press your answer instantly in your calculator. So n is the total number of objects. So how many objects are we trying to arrange? I hope you get that. R is the number of objects selected at the time, and I hope you get that as well. So I'm going to pause for a while. Okay, so I hope you're able to do step 1. There are 4 persons, okay, that you have to arrange. And it says they're in a row. So which means 4 at a time. So R is also 4. Okay, so the solution would be 4p4. Did you get 24 ways? Okay, so it means 4 factorial on top divided by the quantity 4 minus 4, close quantity factorial, which will become 0 factorial. And 4 factorial has a value of 24. Okay, now let's level up with the second example. Okay, try this one. 7 swimmers line up to compete for the bronze, silver, and gold medal. In how many possible ways can winners be declared, assuming that there is no tie? So one winner for each medal. So solution is NPR is equal to n factorial all over the quantity n minus r close quantity factorial. So what will be the number of objects that we have to arrange? And what will be r, or the number of objects that you have to select? Okay, were you able to get that n has 7? Because there are 7 swimmers who would like to get those 3 medals. Okay. R, since you have bronze, meaning that's the 3rd place, silver, 2nd place, and gold is the 1st place or the champion, and there shouldn't be any tie. So we have 3 positions to, okay, to occupy. So the R here is 3. Okay, so therefore the solution would be 7p3 taken at a time. So 7 factorial all over 7 minus 3 close quantity factorial, which will become 7p3 is 7 times 6, 5, 4 times 2 times 1 all over 4 times 3 times 2 times 1, because 7 minus 3 will become 4 factorial. I hope that is clear. Okay, then we can actually cancel the common factors here. Those are 4, 3, 2, 1, 4, 3, 2, 1 here. So what's left in the top part is 7 times 6, which is 42, times 5. Okay, 42 times 5 is 210. So there are 210 possible ways of declaring the bronze, silver, and gold medalists for this competition. So with this practice exercises, I hope you're able to learn what linear permutation is. And I hope that you watch my next video. It has something to do with permutation, but this time it is circular permutation. And the last one, the distinguishable permutation, which is a necessary thing in statistics and probability. So please watch my next video.